So hello guys, today we are going to do a Leetcode question that goes by the name delete node in a linked list. The question number is 237 and it's a Leetcode daily question. I think this is the easiest question on Leetcode. Okay, easiest. It is even easier than 2sum. Okay, 2sum is the first problem on Leetcode, but this is tagged as medium. And maybe it is difficult for someone to think like this because it is not really, maybe like in the fundamentals you are not taught something like this. We'll soon get to know. Okay, we'll soon get to know. So first we'll try to read the problem statement and then we'll go into the solution. Okay, so let us try to read the problem statement, break it down in the parts because as you can see the problem statement is so huge. So we'll be breaking down into parts the huge problem statement just to scare the student, and it has nothing to do with the solution. Like it has to do with the solution, but according to the problem statement the question is a lot easier. Okay, so let us first try to read the problem statement. So there is a single linked list head and we want to delete a node in it. Okay, so what we are given was we are given a single linked list. Single linked list means this single linked list that has only arrows in one direction. Okay, so you are given the node to be deleted node. You will not be given access to the first node of it. Okay, in general cases what happen is I am given the head of the node. Okay, but in this case I am not given the head. Okay, all the values of the linked list are unique. Okay, so no value can be repeated. It is given that no values can be repeated. No values can be repeated. Okay, no values can be repeated, and it is guaranteed that the given node is not the last node in the linked list. So you are given a node, but that node is not the last node. So this cannot be my node that is given. Okay, delete the given node. So you have to delete the particular node that you are given. Suppose you are basically given the access to this, so you have to delete this node. So note by deleting the node, we do not mean removing it from the memory. We mean the value of the given node should not exist in the linked list. Okay, value should not exist in the linked list. Suppose basically if I number this, so 3 should not exist in the linked list. If this is the node to be deleted, 3 should not be deleted. Okay, 3 should not be deleted like from the memory, but it should not exist in the linked list. Okay, the number of nodes in the linked list should decrease by 1. That is a general statement. Obviously if you delete an element, the number of nodes would decrease by 1. All the values before the node should be in the same order. Obviously if you delete this node, if you just delete this node, all the values before it and all the values after it stays the same. Yes, all the values before the after the node should be in the same order. It has nothing to do with the it has nothing to do like it has to do, but like it is general stuff. Okay, just you are described with the question. These are the conditions to be met. Okay, we'll consider this. All the values after the node should be in the same order. Obviously custom testing, for the input you should provide the entire linked list node, and node should not be the last node and should be the actual node. We will build the linked list and pass the node to your function. The output will be the entire list after calling a function. Okay, suppose you are given with this. Okay, 4, 5, 1 and 9. Suppose you are given with something like this. In general cases what we have to do is, when we are given that we have to delete a node, what you do, basically you are given the head of the node and suppose you have to delete this node. What you do is just iterate to this particular node, the node just before it, and what you do is you remove this pointer and you just point to here. Okay, and this node get automatically deleted from the list. This is my new list, but in this case what I am given is, I am not given the access to the first node, rather I am given the access to the node that is to be deleted. Okay, so this is my node to be deleted. Suppose this is my node to be deleted. So how can I delete it? Okay, one thing is you can directly remove it from the memory, but you will lose this nodes and you will lose this nodes. Okay, so see, it seems like a loophole, like a kind of hard thing to tell at first sight, because See, you are given with the questions where you have given with the head of the node, but you don't have access to any other node except this node. Okay, seems kind of tricky, and I think that is the reason, that is why it is marked as Leetcode medium. Okay, because the intuition is not easy to get. Intuition is not easy to get, not very easy to get. Okay, it can be tricky for some. That is why I told you it can be tricky for some, but it is very easy. Okay, let us now go on to the solution. 4, 5, 1 and 9. Suppose you are given with like this. You are given that the node to be deleted cannot be the last node. Okay, at any case it cannot be the last node. So suppose you are given with this node is to be deleted. Delete this node. Okay, what I can do is I cannot simply remove it from the memory. I don't have access to the previous node, as well as I don't have access to the next node. Sorry, I have the access to the next node, but that is of no sense, because if I don't have access to this, I cannot just change my pointer and go to here. Okay, so what can I do? Just think. Pause the video, think for 2 minutes. Okay, I'll tell you the solution. Suppose you have to release this node from the linked list. So can I do like this? I will copy the next node's value into this node, and rather than deleting this node, I'll simply delete the next node. Okay, I'll do it in steps. Basically what you will do is just copy the value of 9 here. Okay, and now it becomes something like this. And what you will do is you will change this pointer and point it to the next of the next node, because you cannot delete the node, but you can always delete the next node. And there cannot be a case when my node to be deleted is the last node. Okay, so there cannot be a case that it runs out of memory, like it gives a null pointer error. This cannot happen in this scenario. Okay, in these test cases. So what I'll simply do is, there are only two steps to be followed. Rather than deleting the current node, delete the node just after the current node. But before deleting, copy the values. Current node. But before deleting, copy next node values into the current node. Okay, suppose you are given with a linked list like this: 1, 2, 3, 4 and then 5. Okay, and this is the node to be deleted. What I'll do, I cannot get access to this. Okay, I cannot get access to this element. So what I'll do is, I'll try to reduce this. Okay, so what I'll do is, I'll try to delete this from the linked list. But before deleting, what I'll do is, I'll copy the data. So this would be like 4, and I'll change the next pointer of this to the next element. So my nodes next should be equal to node of next to next. And before this, what you will do is, node of val should be equal to node of next of val. Okay, so you are first basically copying the value from the next node, and then you are deleting the next node. Yes, this was the solution. This was the overall solution. I'll just tell you one more test case. 4, 5, 1, 9 is the same test case. 4, 5, 1, 9. Suppose you have to delete the first node. Okay, the process remains the same. Just copy the 5 value into this. So 5 comes here. This becomes 5, and the second node, the node just after it gets deleted, so the pointer would change, and this would be like this. Okay, so the new linked list would become like 5, 1 and 9. As you can see, the nodes before it remains same, the nodes after it remains same. Okay, there is no change in nodes order. So this was the solution. Yes, a two-liner code. Two-liner code. That is why I told you it is so easy. I'll try to code it. Okay, what I'll do is I'll try to delete the next node, and for this I'll simply move the next pointer to the next of next. But before this, what I'll do is I'll change the current node's value to the value of the next node. Yes, that's basically just two lines. I'll try to run it. I'll try to submit. Submit it successfully. Okay, so if you are not given the access to the current node, just try to delete the node after it. Okay, but before it, just move the values, move the value of one node. Okay, suppose you are not given this condition, that this node can also be the one, then you can add an extra condition, right? You can always add an extra condition. Okay, so for this case, this is the only code. You're just moving the next pointer, but before this you are copying the values. Okay, so what about the time and the space complexity? Space complexity is O of 1. You are not using any extra space. What about the space time complexity? Just moving the pointers and moving the values. Is it taking any O of n linear operation, n square operation, anything polynomial operation? No. So O of 1. Time complexity O of 1, space complexity O of 1. Okay, so this was the overall solution to the question, delete node in a linked list. I hope you guys like the solution. If you have any doubts regarding the solution, you can just ping it down in the comments. And if you like the solution, do like, share, subscribe. Thank you. Have a nice day. Bye-bye.